and I'll pass it off to Dalton Claybrook. Magic of Sourcery.
All right, thanks for coming to iOSoho. My name is Dalton Claybrook. I'm an iOS developer here at Peloton. As EJ already mentioned, we are currently hiring on my team, so if that sounds like something that interests you, please talk to me, talk to EJ. Anyone else on the team would be happy to answer any questions that you have. So my talk is called The Magic of Sourcery. It's also the title of a blog post by Casey Liss from 2017. I created this whole presentation, then I found this awesome blog post by Casey Liss. It still holds up 2 years later. So I decided, it's a great title. I'm gonna hang on to it, but I'm gonna include that as reference material in the slides. So I'll hand those out afterwards. So feel free to check that out and check out the other reference material. So, what is Sourcery? Sourcery is a developer tool concerned with metaprogramming. So what is metaprogramming? Well, this is the definition from Wikipedia. It's a programming technique in which computer programs have the ability to treat other programs as their data. So we write programs, all of us are programmers, and in the conventional sense, our programs work with different kinds of data. So some examples of that are user preferences, potentially sensor data from things like the GPS sensors, feed data from the internet if you're access an API through your backend or anything. So in the context of metaprogramming, your data is programs. It's a program itself. And so in this sense, we're talking about types, we're talking about variables, enum cases, and others. And so not only is a program your input data, but it's also your output data. And so that's where the code generation comes into play. So Sourcery is a code generation tool. And so code generation can be considered most useful in the context of generating boilerplate. So why is that? Well, boilerplate is repetitive. You tend to write it over and over with a few, if any, changes. You might copy and paste it around your application, or use it in between, use it on different applications, basically the same code in different applications. It doesn't really concern application logic. The application logic is the code that you enjoy writing. It's the code that that your users, when working with, they recognize it as your app, true to your app. And frankly, boilerplate is tedious to write. It's boring to write. It's not all that fun to write boilerplate code. And all this kind of adds up to the fact that it's error prone. It's a little error prone, and we'll see why that is the case a little later on. So consider a code like this, and specifically this helper function here, or helper accessor. How many of you have written code similar to this for Swift enumerations? It seems like it's a pretty common pattern. You want to be able to ask this, an instance of this enum, if it is loading. And you could either do pattern matching, as we actually have already done here in the accessor, or you could write a custom accessor just like this. So it would be great if Swift gave us some support for this right out of the box, but we kind of get limited support with enums for accessors such as this. So we get more support from structs and classes and that sort of thing, but not so much with enum. So we would call this portion of the code boilerplate, because you tend to write this kind of shape. If you squint at it, we write this kind of shape of code in lots of different places throughout our application. So here are a few other examples. These examples come straight from the Sourcery documentation page. Quality and hashing, enum cases and counts. You recognize some of these as things that you've probably written quite a bit of boilerplate for in your career. And fortunately for us, we get a few of these for free in Swift. So over the years, we've been fortunate that Swift has added support for some of these code generation tools straight into the language. So now we don't have to implement equality and hashing for naive cases. We don't have to implement enum cases and counts and iterating. We have things like case iterable for that. JSON coding, we now have access to codable, decodable, and codable. But there's a few things that we don't get. We don't get lenses and prisms. We don't get mocks and stubs. Linux main, so in the context of Linux development in Swift, you would use a Linux main file. Decorators is another use case. We have limited support for decorators now if you in the very specific context of property wrappers for properties. So that's exciting. So we get a few of these for free. So why would we want to use code generation? Swift continues to add more and more of this support straight into the language, which is great. We should always strive to use the first-class support for this kind of thing. And you might be asking, you might be thinking, it's not hard to write computed properties. It's not hard to write serialization code. We've already seen we get a lot of this for free in Swift. So why would we want to use this tool? I want you to consider this other block of code here. Can anyone see a problem with this code? So it compiles. It's not that this code doesn't compile. It's that it's missing one of the messages in the all messages list. We forgot to include the Facebook message in this list of all message types. This, the name of this variable, this array, makes a claim that it contains all message types. But we have broken that claim by forgetting to include Facebook message in this list. And that might not have happened when we first created this array. We may have, when we started our application or started this feature, we had only 3 message types. And later on, we added this 4th. This code may have not been co-located in the same file, so we may not have seen, it wasn't readily at hand, and the developer who worked on the Facebook message may not have worked on the original feature, or just, they've slept since then, so we shouldn't be expected to remember to all the places we need to touch this code. So this is kind of a prime candidate for code generation. So it kind of boils down to avoiding human mistakes. So simple, repetitive code is some of the easiest to screw up. And as I've mentioned already, the problem might not be writing it the first time. Actually, it might be maintaining the code later on. So before we get into usage of the Sourcery tool, let's talk a bit about installation really quickly. There's 2 ways that I'll talk about installing Sourcery today. One of them is through Homebrew, and the other is through CocoaPods. I would actually recommend installing through both of these means because they kind of serve different purposes. Homebrew is for doing rapid iteration on your code generation templates because you can just run Sourcery straight from your command line and you get access to all of your Homebrew dependencies are in your path, so it's easy to run Sourcery that way. But with CocoaPods, that's where you can kind of ensure that it gets brought into other developers' projects, and you can run it from things like a build phase in your Xcode project. And I just want to stress one point. It's kind of stigmatized a little bit in the iOS community around introducing new dependencies to your application. It's not always like the best choice necessarily to introduce a brand new dependency to solve a new problem. But I will stress that you're not actually adding a new binary to your application bundle. You're not shipping Sourcery to your users. You're merely adding the binary to your pods folder, and so that you can access it from the pods folder. But it doesn't actually bloat your application, and you don't have to worry about introducing that dependency onto your end users. So that's good. So how do we run it? So here's an example run of Sourcery. We call Sourcery from the command line. We can pass some arguments. We have a sources folder that we're passing a directory called My Project, a template directory with your Stencil templates, and an output directory with your generated files. But it gets a little bit easier than that if you choose to use a YAML file. So you can see that we have the same information captured in this YAML file. And those of you who use SwiftLint should be familiar with this. This is really similar to the way that SwiftLint is configured. You can just create this YAML file in the root of your project, and then all you have to do is run Sourcery, and it picks up this default configuration. So now let's talk a bit about the Stencil template language. This is the language that you write your boilerplate, the language you write your code generation templates in. So technically, there are 3 languages that you can use when writing templates for Sourcery. And this is just the recommended language. But the other 2 are JavaScript and Swift. And there's a couple problems with those. You might have heard me say Swift, and you're like, why wouldn't I use Swift in my template? I'm generating Swift, so why wouldn't I use Swift in the template file? So one reason is both Swift and JavaScript are slower to run Sourcery with than Stencil, and that makes sense. And we all know Swift, unfortunately, is kind of slow. It's still a little slow to build. So That may not always be a problem, but the other issue is a little more nuanced. So when you add Swift code, when you think about adding Swift code to your code generation logic, I'm not talking about the logic, or I'm not talking about the Swift stubs that you put in place. I'm talking about the actual logic inside your code generation file, the things that are looping and checking conditions and things like that. Really, I would stress that you want simplicity in that context. So when you bring Swift in, when you choose Swift as your language for your code generation files, you unlock the full capabilities of Swift, meaning that you could create all sorts of enums, you could create generics, classes, structs, have complex routines, inheritance hierarchies, things like that. And you really don't need all that power in a code generation template. In fact, if you see yourself reaching for the complexities and the power of Swift from your code generation files, you might reconsider the tool. You might reconsider maybe Sourcery isn't the best tool for this particular use case. So that's why I'm going to recommend Stencil, one of the reasons, and the other being it's just much more popular in the Sourcery context. So here is an example Stencil file. And you can see that a lot of this is actually recognizable as Swift code. So we see the extension declaration, we see a static var, but there's some things that are a bit foreign. The double curly braces, everything inside a double curly brace is kind of the Stencil code, right? Another thing that I want to stress is that this is not running at runtime. This is running before compile time. This is code generation we're talking about. So we have access to things. These things we have access to are available to us. It's information that we can derive simply by reading the source code. So we know what we have access to this type variable, it looks like. We know its name. We know its kind, whether it's an enum or a class or a struct. We know how many variables it has, how many methods it has. And so when you run Sourcery, you'll get one or many of something like this. And so, as you can see, this has actually just generated a static string. This is a string that, in fact, what I probably should have done is declare this as a static string, because that's what this is. It's a static string. It's not computed at runtime. It's declared at compile time, which is kind of cool. And this is always updated with the latest statistics about your application. So that's kind of cool. So let's look at some of the basic syntax of Stencil. We have really these three types of tags. We have the variable tags. We have these this % here, which is actually called a tag. Includes if statements, for loops, macros, and other things. And then, of course, some of you might be familiar with this comment syntax, the hash symbol for comments. It's used in other languages. So we'll look at some examples of variables that you can use inside of a Stencil template. So here you can see we have access to this variable called type, and we can inspect its properties. So we can ask it for a name, and this is a very simple case. Stencil exposes these things called filters, and that's kind of a misnomer. It's not always filtering something. It might just be transforming it in some way, and that is the case in this example. We're not filtering out anything about case.name. What we're doing is we're uppercasing the first letter of this. So yeah, like I say, the filter is a bit of a misnomer there. Filters can have arguments. So this is interesting. You can probably imagine that in some cases this name variable we have a reference to is uninhabited, it's empty, it's nil, and so in those cases we would want to default to this default string value of world to output that. Look at some if statements. Here's a very simple if statement. We're asking this variable if it's optional. Here's a compound expression. And so you'll notice this is kind of a departure from Swift syntax. We're using these English word and not. That's used in other languages, but not typically in Swift. And so you wouldn't use a double ampersand, and you wouldn't use the bang symbol for negation. You would do a pattern similar to this. And you can even use filters. Some filters are used in if statements. And so if statements in Stencil are truthy. So this might return a string, and if it's a non-empty string, then that would be like truthy. That would be like a true, and it would pass this if statement here. So what we're checking is this case annotated with the annotation string auto getter? And finally, we have this inline conditional variable. So you notice that we're using variable syntax here, not the other if syntax. And what we're saying here is, if we're not on the last element of a for loop, we're going to output this comma to our code output, so our generated code. Let's look at some for loops. Simple for loop for type. This should be recognizable. For type in types.classes. So you can imagine we have this global variable types, and it has a field on it called classes, which is an array. We're enumerating that array here. We have dictionary subscripting. So you can see that types has this field called implementing, which returns a dictionary, and we can subscript that with this string, and that will return an array in which we can iterate. But there's also a shorthand notation for that. This is a bit more common. You'll see this more commonly when reading Stencil files. It means the exact same thing. And you can actually use where clauses, where expressions in your for loops. And this is more of a filter. I mean, what we're saying here is, for type in all the types where that type's name is foo. That's more of a filter. We're filtering out everything that doesn't have a name called foo, but it's not called filters in this context. So that might be a little confusing. I want to talk really briefly about the Sourcery API. It's really well documented, so I'm not going to stress all of this. This is kind of a bit of a heavy slide here, but I just want to include this slide to illustrate that there's really a lot of capabilities, a lot of information that you have accessible to you inside of a Sourcery template. These are all the APIs on a type, if you have a reference to a type. Here are the APIs that you have available to you if you have a reference to a variable. So you can ask a variable things like, is it final? Is it computed? Is it static? And so I would emphasize again, if this is something that you're interested in, if you want to pursue Sourcery, Sourcery actually has really great documentation. It uses like Jazzy Docs. If you're familiar with other services that use Jazzy documentation engine, it's really nice to read and parse. Okay, I'd like to do a hopefully not a quick demo. Shouldn't take too long unless I screw it up. So try not to do that. All right, let's take a look. Can everybody read that code? Is it big enough? Should I, or that those files? How's about? Okay, let's take a look at some code first. So we have these enumerations, and what we're going to be doing is we're going to be generating those accessors that we saw in the very first code slide. So we're the isLoading accessor for these enumerations. And the first thing that I'm going to do, it may seem a little counterintuitive, or in the wrong order, but I'm going to start Sourcery because I can pass this argument called watch. And this will be watching my source files, watching my template files, and anytime I make a change, it can regenerate those source files, which is cool. The generated source. So as you can see, I'm generating code now. So in my experience, the first thing you typically start with in a file like this is a loop, accessing that global types variable and drilling deeper into that types variable. So let's do that. So we're iterating all enums. This is a field on types. I'm just going to write this. A lot of this is going to look like normal Swift code. Okay, so you can see we've already generated stubs for all of our enumeration extensions that we just saw, which is really cool, moving very quickly. So let's keep going. We're going to iterate all the cases on that type, and we can ask a type for its cases, and we know that they'll be there because we're only iterating enums. So I'm just going to keep writing what is just normal Swift code. So we want to return a Boolean from this. See what that looks like. Okay, great. So this is we've already done a lot. We've generated code for every single case for every single enum in our entire application with just a little bit of the stencil code, which is awesome. But there's a problem. We can probably all spot the problem. We're not using camel case on our case accessors. So this kind of breaks Swift convention, so let's fix that. And we can do that with a filter. It's the same filter we saw from earlier. Okay, so you can see it's regenerated those with my uppercasing the case there. So let's keep going. We have this case already, so let's write a switch statement. And we have the one case that we know is true. All right. And this is great, okay? We've already returned, we're already returning the true case. And now we need to stub out the false cases. And what we could do is we could throw in a default return false. But typically in Swift, it's considered a better practice to make your switch statements exhaustive, completely exhaustive if possible. And so let's try to do that here instead. So I'm going to make another for loop. I'm going to iterate through the cases again. So let's see what that looks like. We're going to call this one other for other in type.cases. And I'm going to use a where clause here now to filter out that case that we've already stubbed. So we're going to say where other.name does not equal case.name. And we're just going to write this the same way. Other.name, return false. Okay. So this code compiles. This is all we need to do to implement accessors for every single enum, every single case of every single enum in our whole application, which is great. I'm going to clean this up a bit, add a space in between these types. I have my pragma mark, which is nice. Good to use those. So let's look at our code again. So yeah, like I said, we've generated all these accessors, but we wouldn't necessarily always want to generate accessors for every single enum in our application. It doesn't really make sense to do that if we only ever access a few of those enums in this way. And so the way that Sourcery solves this problem, or suggests that you solve this problem, is using what they call marker protocols. So here's an example of a marker protocol. It's an empty protocol. It adds no functionality or no requirements to your code other than to mark a type for use in a Sourcery template. So let's do that with playback status, and we'll update our code generation file here to use that. So I'm going to use types. I'm going to use another property on types called implementing auto enum. And I'm going to add another little bit of safety in here. I'm going to say where type.kind equals enum. So just in case somebody sneaks in one of these to our to something that's not an enum, we won't fail code generation in this way. So you can see it's already removed our other types. Now we're only generating accessors for playback status, which is great. Cool. So so we're almost done here, but if you remember on the earlier slide, the code that we had written, the code that we wanted to generate, was only a single accessor for view state. We don't really access any of the other cases on view state other than is loading at runtime. So it may not necessarily make sense to generate accessors for every single case on this enum. So instead, we can use a tool called annotations to fix this issue. So let's add an annotation to this case. So I'm going to say Sourcery, and we'll call this AutoGetter. So we've added an annotation to this, and now we just need to make that work. We're going to do a similar loop like we did before. Types.enums. And I'm going to add a where clause here, and I'm going to say where type auto enum. I'm going to throw a not in front of this. So I'm going to say, basically what we're trying to say here is that if a type has both annotations and is attributed with this marker protocol, we want the marker protocol to win. And we certainly don't want to generate duplicate accessors, because that would be a compiler error. So that's not what we want. So we're going to only iterate on types that don't conform to that. So this is similar to what we wrote earlier. And OK, we've generated some of these. And so we have an issue. We did not add an annotation to foo, we only added it to view state. So let's see how we would go about removing that from this list. It's not necessarily a huge problem that you would have an empty extension declaration, but just for general best practice code cleanliness, we probably would not want to write an empty extension if we didn't have to. So let's see what that looks like. I'm gonna, let's see here. Let's do another for loop here. This is where we're gonna get the cases in type.cases. And this is where we're gonna use our annotation. We're gonna access all cases, only cases that are annotated with AutoGetter. And now I'm going to use an if statement. And we're accessing this global variable for loop. We're going to say if for loop dot first. And similarly down here, for loop dot last. Okay. So we're removing foo, and the reason for that is we only want to generate this extension declaration on the first case, the first annotated case, and of course foo doesn't have any annotated case, so we'll never hit this this first condition. So that makes sense. So really, all that's left to do is basically paste the same code that we've already written into our code generation file. And it's working, but that's not necessarily, you know, if we didn't have to duplicate code, typically we try to avoid that in our applications. So that's typically something that you might want to avoid in our templates as well. And so we can do that with macros. So I'm going to define a macro, and I'm going to say implement AutoGetter. And this macro is going to take some parameters. It's going to take a type and a case. We need the case, of course, because that's the thing that we're stubbing, but we also need the type so that we can iterate the other cases in macro. And now I am just going to copy this code, paste it up here. And now all that's left to do is call these macros. Call this macro. And you use that with the call keyword, implement AutoGetter, passing our two arguments, the type and the case. Do that down here. And voila, it's working. And it's sharing this code for generating our accessors, and it's generating only the accessors that we need, which is awesome. And we can extend this annotation a little bit further, which is cool. We can use some extra keywords here. We can say begin and end, and it'll generate accessors for everything inside of that begin and end statement. So that's cool. It makes it super flexible to do. And I want to show one final thing here in the demo, and that is a real-world example in Peloton. So this is our application, Peloton. It's called Argon. Not exactly sure why that's the case. If you're looking for trivia, someone here probably can answer that question, but I don't know the answer. So we have this concept of a packet. We call it a packet. It's probably a poor name, but that's what it is. We send metrics to our API throughout a class. And these are metrics that you would gather when doing a workout. So they include things like calories, heart rate, cadence. If you're cycling or if you're running, you might have latitude, longitude, things like that. So this is the full shape of a packet that our API expects. But as you can imagine, this information comes from different sources. So we wanted to be able to create these subtypes, sort of these partial packets. That all kind of get coalesced into one big packet. And so you can see on the right we have some examples of partial packets. So we have a single data source that gives us information about cadence, another one for calories. So this is kind of what you would expect to a particular individual data source to return. And so I actually added a new one of these a couple weeks ago. I added a running packet. So we already have a distance and a speed packet, but we recently introduced a new metrics provider that returns both speed and distance, just generally running metrics. And so I wanted to add a new packet for this specific use case. But I actually goofed. I didn't make this story up for this demo. I actually did goof, and I forgot to add it to our implementation for generating our full packet. So we have an initializer for this packet that takes an array of partial packets, iterates those, and applies the individual fields from the partial packet to the full packet. And this really cost me some time. I had no idea what was going on. For at least an hour or so, I was kicking myself, asking why isn't my data source, my newly created data source, driving and my stats appearing on my workout summary. And it was because, of course, I hadn't added it to that packet generation code. So we thought that was a good, let's see here. We thought that was a good opportunity to implement this. This is a code generation. This file is now code generated. So this is doing pretty much exactly what we were doing before, iterating all of our partial packets, and it's switching on the type of packet. And the cool thing about this now is, since we are keying off of this any type that conforms to this partial packet type, then the moment that you add a new partial packet to our application, the next time you hit build, since Sourcery is part of is a build phase in our application, it'll go ahead and automatically add that that new partial packet to this list. And as you can see, running packet has been added to this list. So that is pretty cool. All right, so here's another interesting use case, a quick use case I wanted to call out. So you notice that the generated code here doesn't actually introduce any new code to your application. It's just purely comments. You don't even have to add this file to your to Xcode or to a target in Xcode. You could just leave it as is. But this is really interesting. This is kind of an interesting use case that you may not consider in the code generation context for aggregating stats in real time about your application. So at the time that I ran this on our application, we were able to see that we have all sorts of different types. And you remember from the slide earlier, we actually have access to tons, potentially 100 APIs on Sourcery that we could use to generate statistics every time we hit the build button about our application. So this is just one other interesting use case that I wanted to call out. So there were some bugs, limitations that I ran into as working through Sourcery tasks and building this presentation. This is not an exhaustive list, but this is something that I discovered going through it. So Stencil itself is not super well documented, and I don't want to say necessarily that it's not well documented. It's just presented in a way that's not typical of documentation. It's more of like a blog. So it's a little difficult to kind of parse the Stencil documentation. I mentioned that Sourcery is really well documented, but it can be difficult to find the answers that you're looking for on the Stencil documentation. So it's based on strings. Of course, this is kind of unavoidable, but anytime you have a stringly typed language or an interpreted language, it can be things can slip by, errors can slip by without you noticing them. This is kind of a quirk that I think I found. I'm not 100% sure that this is definitely the accurate description of the bug, but the way I summarized it is, if a stencil would generate no output, so if I've somehow altered a for loop that causes it to pick up no cases, and I have no other kind of comments or anything in my code generation template, then nothing will change about the last time it generated code for you. So you may be kind of kicking yourself like, why isn't my code being updated? Really, what you have is an error that you made a few lines back, and you would expect Sourcery to kind of fold that down and kind of remove your generated code, or I would, but that's not what happens in practice. Poor support for generics, so you can't use like conditional conformance. Sourcery, if you try to use conditional conformance and then ask a array if it conforms to this type, or ask a type if it conforms to another type, it'll always return true, even if it only conditionally conforms to that type. And then finally, arrays are treated differently than other container types. So I think this is actually fixed, but there is an issue where if you make an array conform to a protocol, it won't actually realize in the context of Sourcery, the code generation, that array actually conforms to that type. So, but I think that's been fixed, and it just hasn't been released yet on the latest version of Sourcery. So hopefully we'll get a new release of that very soon. Okay, so here are some references. I'll make these slides publicly available, but this, of course, the two forms of documentation, the article that I mentioned earlier by Casey Liss, And then this is a great video if you want to watch another video on this topic. Christoph Zablocki is actually the creator of Sourcery and gives, of course, he's fully capable of giving a great explanation and deep dive into how the tool works. So that concludes my presentation. Thank you for coming. So I think we're going to take some questions. If anyone has questions, we have a microphone over here. We have one right there.
1 second. When we say messenger type thing, like social media messaging or like text messaging, email, instant messaging?
Any kind like that. Yeah, just an arbitrary message. Yeah.
Hi, thank you for your presentation. Actually, I had two questions. One is, have you ever seen any effect of having Sourcery in your code base in the build time? And also, the other question is, in your experience, have you found merging these auto-generated files into GitHub, or are you just adding it to the Git ignore? Thank you.
Yeah. So to answer your first question, there is of course, there is an effect, a non-zero effect on your build times. The good thing about Sourcery is that it actually caches previous runs of itself. So if you run Sourcery and then nothing has changed about your stencil or the source code that it's generating, generating these templates for, these code-generated files for, then it's going to just use the cached version. So we found, I think, that caching has really made it so that the effect on our build times is negligible. And then your second question was, do we check in our generated code? We do check in our generated code into our repository. We also check in our pods. So we use CocoaPods. We check in our pods as well. And I'm sure there's cases to be made for both sides of that. But we here at Peloton, we do.
Hey, thanks for the talk.
Yep.
Right here. Yeah, everything was really clear. So that was awesome talk. Have you had any issues as far as discoverability? Like I'm used to seeing code that I need kind of next to the type. So moving it out of the type, any issues with that?
Yeah, it certainly is siloed in its own place, and that's kind of exacerbated by the fact that you can only specify one output folder. So the Sourcery takes a list of arguments. One of those is the output directory, and so I don't think really there's any way around that. But I would say kind of naively that we haven't seen any issues with that. But it's you can potentially manipulate if you don't want to use folder references in Xcode. You could potentially still co-locate those generated files next to the actual files that they affect inside your Xcode project, even though the folder is not co-located with the file that is being generated. So, but to answer your question, we here naively have not noticed any issues with that.
Hey, can you elaborate a little bit on the workflow? You mentioned you have to kick off the build, so it's integrated into your build process. I'm wondering what happens when you're editing side by side, sort of the templates plus the auto-generated code. How does that work? Do you have to initiate builds every time you modify something, or is that a better solution?
Yeah, I would say that probably the better solution is if you're working specifically on writing your code generation templates, then do what I did just as part of this demo, and rather than relying on rebuilding your application every time you want to generate the code, I would set up a watch, run Sourcery, use that watch argument, get your code generation file in exactly the shape that you want it, have it generating the correct code for you, and then kind of turn off your watcher, turn off Sourcery, and then from then on, your build job will pick up any additional changes. But while you're working in the template, I would say do not rely. I wouldn't say to rely on Xcode builds. I would just use that command line tool for that purpose.
Sorry, one more question.
Yeah.
Actually, that reminded me of for merging in the auto-generated files. Do you guys have any automated kind of like reminder on the PRs or anything that in the CI that catch the errors? Like if the person, for example, changes the Sourcery file like it's Stencil but forgot to just like merge the Swift file in, do you have any automated way to just catch those errors?
We do not know. If we have a conflict in our generated code, and this is also true, I think, for at least for me, for our the CocoaPods that we check into our repo. If I notice that I have a merge conflict with the branch that I'm trying to merge into, then I will resolve that conflict. Pick any arbitrary version, either theirs or mine or whatever. I don't focus too much on that. And then just run code generation again with the if there are merge conflicts in your template file, then that's a different story. You would want to resolve those conflicts just like you would any other merge conflicts. But if you have merge conflicts in your generated code, then I would say just rerun the generation and it'll pick up the correct version. So that's what we typically do.
Any other question? All right. Fun fact, if you were at the New York Times iOSoho back in March, Christophe was actually the presenter for improving developer tools. He's the owner of this repo and this tool. All right, we're going to have a 5 to 10 minutes break to change the computers and speakers. So you please have a drink, have some more food, and the bathroom is behind the wall if you need that. Thank you.